So now we'll discuss about the this formula here, which is m1 x minus m1 x1 plus m1 delta x1 plus m2 delta x2 equal to 0. And how did we arrive at this? But before we go into directly this, directly deriving this, something more important to understand is the significance of choosing a reference point or a origin while calculating problems based on center of mass. So we know that the center of mass, which actually is a point in a system where the masses of the entire system can be considered to be concentrated for a two mass system under consideration. We know that the center of mass x bar can be written as m1 x1, right, plus m2 x2, the whole by m1 plus m2, right, where m1 and m2 are the respective masses of the first and the second body. What is x1 and x2? See, x1 and x2 here represent the distance, right? X1 and x2 represent the distance or the respective positions with respect to a origin. So the next question comes, if there is an origin in respect of which the distance are calculated, where should this origin be located, or what are the possible locations of this origin? So when the origin is said to be the center of mass, it is then the equation minus m1 delta x1 plus m2 delta x2 holds, which clearly means that there can be other origins as well. Which all are they? Origin can be either at mass m1, which means you can consider this to be the origin like this, okay, y-axis and x-axis. Or what you can do is you can consider y-axis, x-axis, and this to be the origin. If not, you also have one more case. So this is center of mass and x-axis and y-axis like this. So there are three possible ways to consider origin. Let us go through one by one. So if we have origin to be the mass at m1, or rather placing, if we place m1 at origin, which means if you keep it like this, right, then we have m1 center of mass and m2 along the x-axis where m1 is placed at the origin, and then we are supposed to find out the center of mass. Let's see how. So this is what the graph looks like. m1 is placed at origin, therefore the coordinates of m1, which is x1 y1, should be equal to 0 comma 0. m2 is placed at b, the coordinates are x2 comma y2, and a is the coordinate of center of mass with center coordinates labeled as x bar y bar. Now the question is what is the value of x1 y1? Since x1 y1 is placed at origin, x1 should be equal to 0 and y1 should be equal to 0. That makes sense? Simple. But what is x2 y2? See, if I assume that these two objects, or sorry, not objects, if these two particles O and B, that is m1 and m2, are kept at a distance r, then what is the value of x2? Then x2 should be equal to r, right? What is y2 then? y2 is the y coordinate of this point. This point B is on the x-axis. Any point on the x-axis, the y coordinate will be equal to 0. Therefore, y2 should be equal to 0, which means this coordinates becomes r2 comma 0. Pause yourself here, draw this on your own, place these particles in the x-axis, and then try to write the coordinates on your own. Things will become really clear then. If you have a doubt, you can come back. And we know that the coordinates here are x1 equal to 0 and y1 equal to 0. x2 is equal to r and y2 is equal to 0, right? y2 is equal to 0. So if we have these coordinates, we can then write the equations for x bar and y bar, which we have m1 x1 plus m2 x2 divided by m1 plus m2. And okay, let us first write out m1 x1 plus. What is x1? x1 is 0. So what is m1 into x1? m1 into 0, which means this part of the fraction vanishes, right? What is x2? x2 is equal to r. So we have m2 divided by m1 plus m2 whole into r as the coordinate of x bar when the object m1 is placed at origin, right? But then what is the coordinate of y bar? Sorry, what is the y coordinate here? Since y1 is equal to 0, we can say that y1 is equal to 0 implies m1 y1 is 0. Similarly, m2 y2 is 0, which means this complete fraction becomes 0, or y bar is equal to 0, right? So therefore the coordinates are x bar y bar is equal to m2 m1 plus m2 into r and 0. Therefore we can say when m1 is the origin, x bar is equal to m2 divided by m2 plus m1 into r. All right. So by symmetry, can you tell me what will be the origin, what will be the x coordinate when the mass m2 is placed at origin? Exactly. It should be m1 divided by m1 plus m2 into r, right? Now, when we fix m2 to be the origin, all the measurements have to be based on this m2, right? So all the other positions are calculated relative to this m2 equal to 0. That you can do it on your own, I do understand, but some of us may find it difficult. So I'm just trying to, trying to cover that as well. If you want, you can just go through the next derivation and you can fill the table. I think that will summarize this complete solution here. But if not, if you want to see that calculation in detail, stick on. So this time, what do we have here? M2 is at origin. Maybe I just write it down here. So we have M2 is placed at the position B, which is considered to be the origin, right? And then we have M1, which is placed at A with coordinates x1 comma y1, M2 with coordinate x2 comma y2. Center of mass C, center of mass is placed at C. Oh, well, it occurs at C with the coordinates x bar comma y bar. All right. Now let's see. What is the coordinate of B? B is x2, y2, yes, but where is B placed? B is placed at the origin, which means x2, y2 coordinate should be equal to 0, comma 0, right? So x2 should be equal to 0, x2 should be equal to 0, and y2 should be equal to 0. Now what is x1? x1 is the coordinate, x coordinate of A. y1 is the y coordinate of A. Since y1 is a point on the x-axis, because m1 is placed in the x-axis, y1 is a point on the x-axis, and any point on the x-axis, the y coordinate of that point will be equal to 0, right? So let me just write down these values over here. So y1 is equal to 0. What is y2? y2 is 0 as well, right? So y2 is 0. y2 is also equal to 0. What is x2? x2 here is 0. x2 is also, I'm really sorry for the technical glitch here, something wrong. Yeah, okay, 0. But what is x1? See, x1 is the distance, this distance, right? Distance AB. We know that the object are kept at a distance of, r from each other, which means the coordinate of A should be equal to r. Am I correct here? Or is there a mistake that I made? Yes, I did make a mistake. Why? Because these points over here are on the positive x-axis, whereas the particles lying to the left of this are on the negative x-axis. Therefore, the coordinate here should be equal to, x1 should be equal to minus r, right? So x1 here equal to minus r. Now what is m2 into 0? m2 into 0 is 0, which means this fraction will vanish. So m1 into 0 plus m2 into 0, 0 plus 0. So this complete fraction is 0 now. And all what we have is, I will just write it down one more time. So x1 is now equal to, m1 divided by m1 plus m2 into r, but what should come into picture? Negative. And what is y bar again? Y bar is equal to 0. Okay, so what is x bar? X bar, oh wait, I have a mistake here. So x bar should be equal to minus m1 into r divided by m1 plus m2 when m2 is considered to be the origin. Now comes the most important point here, which is choosing the center of mass itself as the origin. Now here we know that since center of mass is the origin, x bar should be equal to 0 and y bar should be equal to 0 as well. But what's the significance of this calculation? Let us see that first. See, if we were to understand that x bar, which is equal to m1 x1 plus m2 x2 by m1 plus m2, similarly y bar are the coordinates of center of mass, which is now kept at origin, then this value should be equal to 0. This value should be equal to 0 as well, right? So we have from this, what is x1? x1 is the x coordinate of A. x2 is the x coordinate of B. Now since both of them are kept at a distance r, let me introduce another variable to differentiate this. So let us say r1 is the distance between center of mass and A. r2 is the distance between center of mass and B. In which case, what is x1? x1 is r1. What is x2? x2 is r2. What is y1? As in the previous case would be 0. As in the previous case, y2 will also be equal to 0. And therefore, since y1 and y2 is equal to 0, this complete fraction is now equal to 0. Therefore, y bar is also equal to 0. But what about m1 x1 plus m2 x2? m1 x1 plus, oh yes, you got it correct. I did make a mistake here, right? Which is r1 is not positive. r1 should be negative. Why? Because m2 is now, which is the position of B, is along the positive x-axis, whereas A is placed along the negative x-axis. So if we rewrite this equation, what we get is m1 into, right? What we get is m1 into, what is x1? x1 is minus r1 plus what? Plus we have m2 into, what is x2? x2 is plus r2. And what is this equal to? Equal to 0. And therefore what we get is m1 r1 is equal to m2 r2. Okay? So that's how we get these three cases. When m1 is at the origin, expression of center of mass is m2 divided by m1 plus m2 into r. When origin is chosen to be m2, then the x bar is m1 into r divided by m1 plus m2. And when it is center of mass, then we know that x bar comma y bar is equal to 0 comma 0, and therefore m1 r1 plus m2 minus m1 r1 plus m2 r2 is equal to 0. Okay, so that was the concept behind this. So this is the most important the calculation of origin based on center of mass. Now I do understand that we have not discussed the solution based on these three cases. Now the next three solutions, right? Those will be: 1, calculation of the same change in displacement based on m1 to be origin; 2, calculation of the displacement in M2 considering M2 to be the origin, and 3, center of mass itself as the origin. Okay.